diary. So we previously had a hardware walkthrough of the Cromemco Z2 system, my computer that dates back to approximately 1978. And today we're going to go through some of the software which is still running on this computer. So to start off with, I'm going to start the resident disk operating system. Hit enter a few times and then try and break out of it. Okay, I'm trying to press escape. So Cromemco had a resident disk operating system, which was a ROM, a read-only memory, which sat on the floppy disk controller starting at hex C000. So that is in the 64K space of the Z80 processor. And the idea was that when the machine powered up, you would need to disable memory, your RAM memory, at C000 and above. So what Cromemco memory users had was something called bank select. So you'd select your memory to be available at power on, except for memory, let's say, above the 32K line. If you had a 64K system of maximum memory, you could tell it to disable a portion of that memory, certainly including C000 to FFF or Fs. And later on, that could be enabled by writing a command to the hex port 40. So the bank select port was 40, and indeed this was used with great effect to have a multi-user, multitasking operating system, which was called Cromix. And what they did is they split 64K memory code into two banks of 32K, and the upper bank was switched in and out between different users. Anyway, that's a long aside to say that when I start the machine, the ROM is visible and the CPU jumps to C000. So that's what it's just done. And it's running the RDOS resident disk operating system. So there's various commands you can do at the RDOS prompt, but what we're going to do is we're going to type BC, which means boot to the C drive. Now, when you configure the CDOS operating system, you have to tell it exactly what drives are what size and how many what density and how many size, etc. So this has been configured precisely to represent this machine over here. So we're going to type BC. Now those noises are the noises of the simulated drive. So you see we've booted the C drive, and if you do a stat of the C drive, you'll see that this is quite a large diskette by diskettes at the time. So this is a double-sided, double-density 8-inch drive. And in fact, we've got 0 kilobytes of disk space left. That's very well done. And we've got a massive 1,208 kilobytes used by files. We've got a 464K of memory, of which the operating system is taking 15K. And that leaves us with 49K of memory to play around with. Here you can see we've got different devices. So we've got the console, the printer, the reader, and the punch. I never used to use the reader and the punch, but certainly you could reassign the printer device to another like the serial printer or the parallel printer. If we look at what files we've got actually on the actual system, so if we do a dir command, you'll see we've got a lot of programs on this system. So we've got a COBOL. We've got the CPM debugger. We've got the basic, which is Cromemco basic. We've got an assembler. ASMB would be the assembler. I don't see that. We've got ASM22, that's the CPM assembler. We've got the drivers file, which is the Z80 source to the character drivers for the operating system. So you could edit that file and change the way that the character drivers behaved. not the block drivers, not the drivers for the disk drives, which were never formally announced, but the character drivers you could play around with. We've got the 68K memtest program, because this Cromemco computer, as I'll show you soon, has not just a Z80 processor, but a 68,000 processor on it as well. And you can jump from one to the other. So this is a program which is written in 68,000 and Z80 code and jumps from one to the other to do the memory testing. We've got the CPM macro assembler. We've got some overlays here. They're part of the WordStar word processing package. We've got the screen editor. We've got WordStar, the word processing program, for a VT100 base screen. So in the olden days, you'd connect a character-based terminal across a piece of wire, and you'd use an RS-232 serial interface to talk from the computer to that terminal. And things like clearing the screen or inserting a line or deleting a character were functions performed at the terminal, and the computer would send what's called an escape sequence from the computer to the terminal for it to do that thing. Now, unfortunately, the escape sequences for every terminal are basically different. So this program here, Witto, I called it Witto, was a WordStar for the C80 terminal. So we'd bought a C80 CT101, I think it was called, CIT101, which was a DEC VT100 clone, if you like. It was slightly better than a DEC VT100 in terms of performance and price, certainly price. So effectively, this is the WordStar program converted to run with the escape sequences for a VT100 terminal. Now, right today, I'm using the screen program under Unix, or effectively macOS, which is sort of Unix. And the screen program tries to emulate a VT100 program, but it doesn't do a very good job. So none of these screen-based programs are going to work today, which is a shame. And I've forgotten again to turn on the light. So again, it's like Hammer House of Horror. Alexa, turn on face. Nothing. Alexa, turn on face. That's better. So you can see there's a lot of programs on this disk. I think we're nearly at the end. Oh, there's a few more. That's the WordStar overlay there. I remember that. And there's some more diagnostics programs that I added just the other day. So I thought I'd run a basic program. So we have a fancy basic here called Structured Basic. So I'm going to load that. I thought I'd give you a real-time loading there. That was the time taken to load a 32K program from a floppy, quite a fast floppy. So you'll see a program called Prime there. So I've written that already. So let's do a load of the Prime program. I'm going to list the program. So I think most of the effort this evening has gone into producing this program. I was trying to make it efficient, so I'm testing for prime numbers up to a certain number. And you can test that by dividing the number you're trying to test from 2 up to effectively the square root of the number you're trying to test. So if you're trying to test, let's say, 9, you only need to test up to 3, the square root of 9. So you test the divisors of integers from 2 up until, in this case, 3. So it finds the square root here, and it checks a trivial case where the number is a square. And if the number is not a square, it tests from 2 up to that integer limit and see if there's a fraction. So if we run this program, then I'm going to say let's test up to number 100, and you can see it's working. What great programming. Okay, we're going to take by to get rid of that. So you can see we can run character-based programs. You can do some screen manipulation, but of course, if you write a program in BASIC, then you'd need to know what output device you're writing to. There's no like programming library which would translate to the codes that you need for your particular terminal. That hadn't been thought about at that time. What else can we show you? Well, we've got a B drive, which is a large drive, so we can format that drive. So I can say init program. And we're going to select the B drive. And we're going to say it's a Cromix, sorry, it's a CDOS disk, double-sided, double density, start at cylinder 0, finish it, I think that's 76 decimal. We're going to do both the surfaces and sides. And hopefully you can hear that formatting. Now, when that finishes, we're going to try and transfer the operating system from the C disk to the B disk that we're formatting and then try and boot from it. And that'll be a good test to show you of the tremendous speed of computers in about 1980 based on floppy disks, and also the fact that it's quite advanced actually, that you can actually boot from different letters of drives. Early CPM machines could only boot from the sort of first drive, but Cromemco had a better product. We'll just call it B disk, shall we? We'll leave the date blank, and we'll say 256 files can be stored on this diskette drive. We're going to do, so to write the operating system, you can write the bootstrap by saying write system from the B drive onto the B drive from the existing C drive. Oops. B drive from the C drive. Come on, girl. And then we're going to copy over the operating system itself. So this is writing 8 kilobytes of information roughly into the boot sector area. So we're going to say exfer, which means transfer, from the onto the B drive, from the C drive, the program called CDOS.com. This is about a 10 kilobytes of programming. "14 kilobytes of programming, which took multiple seconds. So you can see we're probably getting something like 3 kilobytes per second transfer. So we can reset the computer by running the RDOS program. And then we're going to try and boot from the B drive, which we just made. We can go back into the monitor. We're going to load, right, we're going to break out of it. And we're going to boot from not the C drive this time, but the B drive. And if things go according to plan, it's going to work. It's working. We'll have a little look, and there's only that file is visible. We've got a massive amount of space free. Look at that. Okay, so that concludes the Z80 CDOS demonstration. What I thought I'd do now is do something much more fancy, and we are going to look at booting the computer into the Unix-like Cromix operating system. So now what we're going to do is show you the computer rebooted into the predominantly 68000 processor. Again, Cromemco was quite clever when it migrated from Z80 to 68000. First of all, it had a product called Cromix, which was a multi-user, multitasking operating system, very similar to Unix. And that was running on a Zilog Z80 processor, which is an astounding feat. And then they produced this dual processor card having Z80 and 68000 processor. So they thought a clever way of migrating to a fully 68000 based operating system was to do it in stages. So they had a way of switching between the Z80 and the 68000 processor, and indeed the first 68000 operating system they released still relied heavily on the Z80 processor. So the brilliance of it was that they could, over time, convert their operating system from Z80 code to 68000 code, which is what they did. So first of all, in this demonstration, we're going to get the hard disk working. Now, we've got an emulated hard disk, and this is the Linux-based computer which I showed you in the previous video, which just behaves as a hard drive. So I've put the commands in the message of the day file. So this is the Linux computer, nothing to do with Cromemco. It's just a disk. I've SSH'd into it, and I'm just going to run these two commands to get the emulated disk running. And I'm going to try and leave the disk maybe running in the top right hand corner so that you can see the disk kind of working. So that's copy that. So the disk is already mounted, that's fine. And then I'm going to copy that. Sorry, I've got a cat in front of my screen. I can't see anything. Baby, can you come over here, please? Come here. Sweetie, come on, over here. Come. Listen, no one's going to be watching. No one's going to be watching me now. Okay, so we started up the hard drive emulator. The hard drive emulator is now running. We'll put that in the corner. Put that over there, shall we? And that's the hard drive emulator for this, like I say, system, which is based on a Linux computer all by itself. So now there's no easy way, but for me to fully hardware reset this computer, I need to go back to the computer and reset it. Okay, so we're going to now boot, but in a much fancier fashion. So I happen to know that partition 6 is the partition we need to boot to. So we're going to boot to partition 6 of the hard drive, and you should be able to see on the right hand side that we're going to get some activity on the disk drive. Let's give it a go, shall we? Show you all the seeking going on. In fact, this disk is so large that we can even get a timeout. The firmware is trying to get to the hard drive and only waits so long and says, well, it must be an error. Because they didn't envisage that you could ever have a hard drive with 1536 cylinders, I think. Oh no, we've got it. Selecting. So now we're doing a memory test. So this is already in 68000 mode because you couldn't have this much memory on a Z80 processor. So now, when you configure the operating system, you can configure the bootloader of the main operating system to either boot to a specific major and minor device, or you can have a question here. So this is being configured to ask the question. So I'm going to say major device 6 and minor device 6 again. So that should work. So we're booting. This is the message that I put onto the operating system in 2021. And it's running its startup files. So it's creating a RAM disk. Now it's asking you to create a time. I'm going to say, because it actually is, it's the February, it's the American format, don't like it, and it's date year 124. And the time is 22:33. Right, we're up to. Now it's doing an automatic login. I'll show you why that is in a second. So if I type out the TTYs file, so many of the commands are Unix-like, and in many cases they quote try to improve on Unix commands, which was a bit annoying in the sense if you actually knew Unix, then you'd want to use the CAT, the cat command. But of course, Cromemco renamed or choose to use the TY for type command instead. So, and there is no cat command, for example. Okay, so you could make an alias in the latest release of the shell, I think, but I didn't ever do so. Right, so if I look at the TTYs file, you'll see that this system can have multiple terminals, and as configured, there's a console and a number of dumb terminals, which would be connected over things called TUART cards, and you've got one terminal here on the Octart, which is an 8-port serial card. And in this operating system, you can have personalities. So I'll show you in a second. There's some personalities here. So this has got the Octart has got a personality of VT10, as has the console. And on the first column here is the run level. So if you were to say init space a number, it changes the run level. So if you have run level of 2, it means to say that any terminal that's at 2 or lower is configured. And similarly, if you have a run level of 3, then it would include all these other terminals. So, in terms of terminal personalities, this computer now has something called a term cap, which again borrows from the Unix world. So if I say more of /etc term cap, you'll see that I've got the file name wrong. So I'll use the D command, not the CD command, to go into the etc directory. Let's have a look of term anything. That's wrong. Let's have ter anything. And it's term caps. Of course it is. So it's more of term caps. So you see, this has a terminal definitions file, which is just like plain vanilla in Unix. Now, don't forget, in Unix, you've got term caps and term info. This is term caps. So they're the Cromemco terminals, which probably no one's ever seen. Televideo terminals, and it had to be right at the end, or if it's not, is it not in this file? Oh, right, that's the Hazeltine Esprit terminal that I also used to use predominantly. So that's good. I put that in as a special definition. As you can see, my definition's nice and neat and tidy with just one thing on one line. And here we have the DEC VT100. So, so for example, you can see here, this is saying it's got 80 columns. And you can see here this is saying to address the cursor, you're sending an escape character plus an open bracket plus a parameter which is the something like the integer of a parameter and then a %2, I forget what that means. And the down, to send the cursor down, it's escape, open bracket B. So that's the sort of thing. So that's handy because when you write a screen editor, you can say to move the cursor up or to erase from the cursor to the end of the line. You don't need to have the actual escape characters. You actually can say what is the terminal type, and then what is the escape. Please, what is the escape sequence for from erase the cursor to the end of the line? And so it's basically you can write a program which is ASCII terminal independent. So that was a very important step forward, and Cromemco didn't think of that, but that's just what they used. So, by the way, so if we go to the root directory, you'll see there's a file system structure. So if ls-l of the root, you'll see that we have a number of directories. And just like in Unix, you have a bin directory, you have a etc directory, and you have a devices directory. So if you look at ls-l of the devices directory, you'll see, yeah, there's, I thought I'd kept it to a minimum, but obviously I haven't kept it to a minimum. I'm not sure scroll works under Unix screen command. No, it doesn't, does it? It's just Apple operating systems. Don't get me started. Let's do a ls-l of the /dev directory. Can I pipe it into more? Is that going to work? Yes, it does. Yeah, so obviously the Unix pipe command works as you might expect because this is a very Unix-like operating system. So I wanted to just show you there's a dev directory, and in the dev directory you've got devices. So FDA is floppy disk A, FDB is floppy disk B. It was last played around with on 2021. It's got access permissions for the owner, which is system of read, execute, write, and append. And it's got the access for the group here and for others here. So again, it's very Unix-like. In fact, Cromemco always used to say it's better than Unix because you've got this extra permission flag, which was not just read, execute, and write, but also append. And again, just like Unix, you have a major and a minor device number, and actually that relates to the driver table entry on the operating system. Okay. So for Cromemco systems, you have a gen directory, and in that directory, you can generate an operating system specific to your hardware configuration. And if I'm more, the latest file, which is 2023, I say star.cromix.sys, that relates to a file, this file, which is in my notation the 4th of February 23. That is the, I'm trying to look at the binary file. That didn't go well. What I meant was, start that again. What I meant was the sysdef relating to that. Now I don't have, right, if I do a more of sys, let's just do a more of sysdef. And you'll see, yeah, this was updated in February the 4th this year. So I've changed it. So you can define things here, and this relates to the character and block devices in the /dev directory. So if you see the character devices are all there, here the block devices. So the first block device is the floppy driver, then you've got the uniform floppy driver, etc., etc. So you build a custom operating system based on these definitions here. So for example, if you wanted to have a RAM disk, you'd need to put this in here and regenerate the operating system. If you had a hard drive, because this can run from a floppy, although it's quite painful, you would put a a definition in there. So by the way, I ran the system for years with just 3 huge 8-inch drives. So I had, I think, 2 drives for the operating system and 1 drive for the data. So the operating system was running basically on 2 megabytes of disk storage, and the data drive was 1 megabyte, which I would sort of mount and unmount, for example. And that's before I had saved up enough money to have a massively expensive hard drive and a massively expensive hard drive controller. Literally each of those items were the price of a car. So that's I forego the price of 2 cars to have a hard drive and a controller. There's not much to show you. If I go into the bin directory and look at some of the programs, you'll see that there are a whole host of programs here. And this relates to not only the Cromemco programs that came with the system, but some of the other programs that I would stick in there. For example, sbasic you saw in the previous part of the video. If I do ls minus l of sbasic, I think that's a directory. Yeah, there's some programs. Again, these dates are actually correct. These are programs that I first had here on the system in 1983, and sbasic.com is the actual program. Now, Cromemco had a system that comes from Unix effectively, whereby each binary has a magic number. So if I do version of sbasic.com, you'll see there's no version number. What an example. Let's do version of one of their programs so we can hopefully get something that we can see. Let's do version of version.bin. So all of their programs were originally Z80 programs, but over time they converted them to 68,000, and well, 68,010 was the latest version. So you can see here that the version program itself is actually 68,000 program. Any com program surely would be if I do ls minus l of star.com. See, unfortunately, sbasic was one of the last programs that they wrote, so I really thought that would actually be have a version number embedded in it, but I don't think it does. That's minus l. There's ASMB, which is the Z80 assembler. You can see on the right hand side, you can see the hard disk is being used and working quite well. So I do a version of tstar.bin. Will I find any Z80 programs that have got version numbers? Oh, untab was one of my programs, and I haven't obviously set the yeah, so some of these are my programs. RB means relocatable binary. Yeah, so 68 means 68,000. RB means relocatable binary program, and you can see that's one of my programs, and that's working fine. So you can there was a help system here. So if I say H of version, that's the help that I wrote for. No, that's their help. They can do version minus V, and you can do version minus C. Can you do both at the same time? So if I say version minus V of untab.bin, version minus C of untab.bin, version minus v of untab.bin. So I've got a cat. It's now sitting in front of my screen. I can see nothing. Literally, I can't. Just wait, baby. Here, come on, please, come on, move. Jump. Thank you. So now we've got CRC OK. I can see it says a 68,000 program, and it's CRC OK. I think she wants to go. So one second. We're back. So you can see I've now set the CRC for the untab program. So that's the program I wrote in 68,000, and it's been compiled and is now untab.bin. Okay, and I might even, have I written a help? Oops. I have. Yeah. Did I say where it was? Where the code is generated? I did not. No. Okay, I'm trying to think what else to show you. Let's have a little look again at the root directory. So if we have a look, we'll see that the operating system is 138,000 bytes in size, and that's been generated from the gen directory. The RAM directory, again, is something that I created and is created on the fly. That's a RAM disk. You have different modes, and the mode command can be used to look at the characteristics of all the character and block devices. So if I do, this is not a rehearsed video, and I'm trying to go back 40 years or thereabouts to try and remember what the commands are. So if I look at, if I do mode, if I do who's logged on, okay, I think I wrote this good. Yes, okay, that's my command, and it's failing because I've not defined the T device. If I say who is logged on, right, /dev console is logged on, that's me. And if I do mode of console, you'll see that there's a whole set of characteristics that are printed out. So I'm running myself from a UART terminal, and again, this is far superior to most plain Jane Unix at the time. These are all the characteristics that terminal driver has been set. And similarly, I think if I do mode of RAM, because that's a device, will it show me the RAM device? ls -lof /dev/ RAM disk 0, yes. So if I if I do type of the etc startup.cmd file, which is this logon file, you'll see that to start this system, more of /etc startup.cmd, we use the command make RAM to make a RAM disk. So I'm trying to show you, if I do more of etc make RAM, we'll see that that script, which is called etc make ram.cmd, because that's what scripts are called under Cromix, or not. Command, sorry, more of /cmd /make ram.cmd. You see that creates a RAM disk, and then copy these files into /RAM. So it makes the RAM disk here, then it mounts, then it makes a file system with the makfs command. If there's no error, then it mounts the RAM disk onto the /RAM. Then it chones the permissions to be owned by the bin user, and then it does the copy. So the device is called RD0. Therefore, if I do mode, it's all a long way to get to show you that if I do a mode of RD0, you've got the actual characteristics of that bit of hardware. So it's telling you the hardware address, it's telling you the size of the drive, and it's saying verify set on. And version would, I've just noticed that's interesting, the version would be the version of the operating system. Actually, that coincides with the version of the operating system. So yeah, it's a good thing to know about. ls-l of /dev/st anything. STD31. I wonder if I do a mode of STD31, which is the whole hard drive, the first hard drive. Wow. Do you know, I don't remember ever having done that back in the day. So this tells you that the hard drive, looking at the entire hard drive, it's got a verify set on, it's got a sector size of 5112, it's got 16 surfaces, which is correct, and it's got this number of cylinders, which is enormous, and it's this size, which again is far bigger than the 20 megabytes of the time. I can actually do the disk info command and do std31, and that will show you exactly what's on this disk in terms of partitions. Okay, so this is a pretty big disk. This is the disk that's simulated here. This is a window. This is a Linux window onto the Linux. This is a command line window, which I've SSH'd into on the Linux computer that's providing the hard drive for this old system. So you can see that this drive has these partitions. The first partition is 48 megabytes, then 8 megabytes. I happen to know that the partition 6 is the partition that we're booted from, and partition 7 is the partition that I've created for all the data. Now again, if you're part of the Cromemco the Google Cromemco users group first, and then you've elected to join the GitHub, you've got access to an image of this entire system. So should you have another hard drive controller, this exact disk image is available on the Cromemco GitHub. So if you're a Cromemco user, then please look at the Cromemco Google group, and there will be a post on how to take advantage of the Cromemco GitHub, which contains a precise image of this entire hard drive, which you need to unzip, uncompress, and stick together to get it right. So for example, if I do an ls of minus the final talk walkthrough, look at the root directory. I think I've created a file, because under Cromix you mount onto files, not directories. So there's a file called /m, and we have a partition of std7, I think. So if I do a mount -r for read only of /dev/std7 onto /m, you can see on the right side the disk activity here. That's done it. If I type the mount command, you see that. Does df work? No, it's not there. But you can see I've mounted that partition onto that directory. So if I go into the M directory, you'll see that disk that partition is just full of sources. So that's got all the sources for various things. It's even got the source for Unix and version Unix v2. And these things, this runs on the 68020 processor only, and this runs on the 68010 processor, but it does require a memory management card, so I've never actually got it to run. And these are some of the other things that you couldn't get access to. So if we look at editors, for example, there's only one editor. That's, I think, Simon's Pickering, I think that's the right name, SE editor. And if you go into disks instead, that means, where are we? SM/disks. You'll see we've got some disks there that you can unpack. Okay, I think I've run out of steam, and my princess has gone, so I think I've totally lost motivation. But I hope that gives you a good little run through of the Cromix operating system. I can't show you the screen programs running because this screen window is hopelessly inadequate and doesn't emulate a VT100 to the extent that I need to show you programs running. But suffice to say that this computer can run any CP/M-based window-like program like SuperCalc or WordStar or screen editors of the time. I did run SBasic under the Z80 CDOS operating system. That, of course, will still run on this computer because when I type SBasic, it jumps to the Z80 processor. It realizes that that's a file and it can still load the Z80 program. So that's pretty clever. Okay, let's shut this old girl down. And now I'm back to the hard drive that's being emulated here. So I just need to break out of that with a Control-C. I'll do a sync command because I'm an old-fashioned Unix guy. We'll do another sync command, shall we? And then we're just going to do a sudo shut down -fast now. And that should shut this Linux computer down, and then I can do a hard power off. Oh, it's wanting me to type in a password. Okay, that's fair enough. Closed. And I can Control D out of that, and I can Apple W out of that. So now we're all shut down, and thank you very much for watching.